Every recovery begins the same way. A call, a location, a disabled vehicle, but sometimes, when we arrive, the scene is not just a stuck machine. It becomes a complex physics problem, where a single small mistake can make everything far worse. In those situations, the first thing we learn is this: don't rush to pull. Before any cable is hooked, before the winch starts turning, we have to understand one thing clearly: where the forces are acting. And if we pull, what will happen next? On a construction road covered in gravel and mud, a multi-ton excavator was stuck on a narrow incline. The operator tried to move it out, but each attempt to climb forward ended with the entire machine sliding back down. At first glance, it looked like a standard recovery, but a closer look revealed the problem. Part of the undercarriage was lodged against a hard edge of ground. If we pulled directly from the front, the force wouldn't free the obstruction. Instead, it could twist the frame. That meant one thing: before pulling, we had to completely change the approach. The main cable was attached to a lower point on the machine to reduce torque. A secondary line was added to stabilize it and prevent lateral rotation as tension increased. When the winch engaged, the force built gradually. No sudden jerks, just steady tension working against the resistance of soil and steel. Then the bind released. The excavator began to move slowly up the slope. Within minutes, it was back in a safe position. A small detail, but if missed, it could have turned a simple recovery into a major accident. At a rural intersection, a cement tanker weighing over 125,000 pounds had slid off the road into a ditch. The front of the truck sat nearly a meter below road level. All the weight had shifted to one side, leaving the entire structure heavily tilted. The biggest challenge wasn't just the weight, it was the cargo. Cement doesn't behave like other loose load. When tilted, it shifts unpredictably, constantly changing the center of gravity during recovery. Pull too fast, and the entire truck could roll over. We deployed 2 recovery units to split the load. One focused on lifting the front end out of the ditch. The other stabilized the tanker body to prevent lateral rotation. Cables were arranged so that forces acted from 2 different directions.
Не зажимаю, я же чувствую. Я чувствую.
The team continuously reassessed the situation, checking the frame, monitoring the ground, and preparing for multiple scenarios: pulling, anchoring, winching, and controlled lifting. Poor terrain, cold weather, and existing damage made the process long and complicated. As tension increased, the mud-covered wheels groaned under load. The wet ground made every movement harder to control. But as the front end began to rise, the center of gravity slowly shifted back into a stable position. Inch by inch, the multi-ton tanker returned to the road. No dramatic moment, just precise coordination and patience. If a standard truck rolls over, the main issue is its own weight. But when that truck is loaded with scrap metal, everything changes. Look at the scene, it's chaos. The entire container has spilled onto the road, forming a massive pile of twisted steel weighing tens of thousands of pounds. Some of the load remains trapped inside, pulling the center of gravity heavily to one side. If we tried to upright the truck without addressing the load, the torsion could snap the frame, or flip the vehicle the other way. So the first step wasn't lifting the truck, it was reducing the load. Equipment was brought in to clear scrap from the scene. Only after most of the weight was removed did we begin attaching cables to the main frame. Two winch systems were deployed simultaneously, one providing vertical lift, the other applying horizontal pull to control the rotation path. This is essential in rollover recoveries with loose loads like scrap metal, where the center of gravity is constantly shifting. For a truck weighing between 25 to 40 tons, the required pulling force is typically at least 1.25 to 1.5 times the load being moved. That means each winch must deliver roughly 15 to 25 tons of force, depending on angles and surface friction. In practice, recovery teams often use 30, 50-ton winches to maintain a safety margin. As the truck body began lifting off the ground, the scrap inside didn't stay still. It shifted, slightly but enough to constantly alter the balance. Just a few centimeters of movement could change the entire tipping moment, risking a reverse fall. That's why the pulling force is never fixed. Operators must continuously adjust, reading cable tension, body angle, and suspension response in real time. Eventually, the truck returned to its wheels, but the job wasn't done. The road was still covered in debris, requiring hours of cleanup. In recoveries like this, righting the vehicle is only half the work.
Alright. Will these outriggers go up and in? Peace out, y'all. On to the next one.
Three completely different vehicles. An excavator stuck on a slope, a 57-ton cement tanker in a ditch, a scrap truck overturned in the road. The only thing they share is a simple truth. In heavy recovery, there is no fixed solution. Every scene is a new problem, a different pulling angle, a different center of gravity, a different risk, and sometimes, the most important thing isn't finding a way to pull harder, it's stopping long enough to understand exactly what is holding that mass of steel in place. Only then can we find a way to bring it back to safety.